Good evening, everyone, and this is lecture number 6, and we are dealing with simple harmonic motion SHM. Yes, beta. Saying something?
No, sir, nothing.
Okay, we are dealing with SHM, and we are dealing with springs and blocks, and we had seen different types of questions where springs were there, blocks were there, and we had found out, and we have seen how to find out omega and time period, and in which case what is the amplitude and things like this. If you remember the questions that we had done, and these are the most prominent questions that are going to come, where they ask you what is the what will be the time period. If this is the case, what will be the amplitude, and so on. Most of the questions, they all rely on finding out the amplitude of SHM, because once you get that amplitude, everything becomes quite simple to understand. So now let us do 2 or 3 problems, and maybe in a different problems are now in more in the form of questions, and this is how questions are made, and these are the sort of problems that will appear in your exam. So I will now put this, and this will help you understanding the basic concept of SHM. So this is the first problem that comes for you. Problem number 1. Now understand the problem correctly and then try to solve it. The system is in equilibrium and at rest. Now mass M1 is removed from M2. Find the time period and the resultant amplitude of the motion. Spring constant is K. These are the ways questions are going to be put. I'll give you 2 minutes to think about this. If you can give me the answer for this one, I would be very happy. 2 minutes you have. Let me put this question in a different way. Okay, let us forget about this question and let me ask you this one. To now try and put your attention on this question. This is a spring of spring constant K, and it is a hook like this. Now, what do? I put on this hook, the spring is hanging, and I put on this hook, a body of mass M. I put on this hook a body of mass M and I leave it. What will happen to this body?
It performs SHM.
You understand what is the scenario?
Yes, sir.
Spring is hanging freely, natural length. When it has a hook, I put a block on that hook and leave it. It will perform SHM, yes or no?
Yes, sir.
You have to find out the time period and amplitude of the SHM and the maximum velocity. What is the maximum velocity of the particle? Can you do that?
Yes, sir.
You have 2 minutes to solve this. Do that first. You can do this question, Nana.
Sir, time
Got the
period is
answer?
equals to 2 pi under root M1 by K.
Time period will be equal to, so I have answers for this one. Time period will be equal to 2 pi under root M.
M1 1 by K.
I hope you have read the question correctly, my dear friends. M1 is removed from M2.
So M2 by K, sir.
M2 by K. That is the first part. Yes. What is that?
Amplitude is equals to M1 G by K, sir.
Very good. Amplitude will be equal to m1g by k. Do we understand this, how this is done? So previous though, once it is in equilibrium, the equilibrium position will be m1 plus m2 g by k. Yes or no?
Yes, sir.
But when you now take it out, it will only go up. Now the mean position, you understand now?
Yes, sir.
If I hope I'm able to make you understand. This is L naught and it is extended originally. How much is the original extension? If I
That
call
is
this as the original extension, this original
x1
extension will be m1 plus m2
into G by K
into g. Oops, written it wrongly. So this will be equal to m1
plus M2 into
plus
G by
m2 into g by k.
K.
Now, when you remove this m1, the equilibrium position will be here, somewhere here, x naught, and this x naught will be equal to
Into
m2g
G
by
by
k.
K.
Go up, go down. How far will it come down? It will only come down to this position. Yes or no? This is the extreme position. Yes or no?
Yes, sir.
And this one is the mean position. Yes or no?
Yes, sir.
You subtract the extreme position from the mean position, or the mean position from the extreme position. You will get the amplitude. The amplitude is m1g by k. We understood this question? Yes or no? Yes or no? Huh?
Yes, sir.
Then, sir, this question, sir. Once you get your amplitude, rest, everything is pretty simple. These are the type of question I love because they mix two concepts together. So this is a question that is coming up for you. The left block in the figure, this is question number 3. The left block in the figure collides inelastically with the right block and sticks to it. Find the amplitude of the resultant simple harmonic motion. I will give you 2 minutes to solve it. If you can do this, that means you are doing great. So how are we supposed to do this? And different ways in which you can do this. This block is moving with a velocity v. It collides inelastically. That means both the blocks will be moving together. Yes or no?
Yes, sir.
With how much velocity?
V by 2, sir.
We have found it by law of conservation of momentum. Do we remember this?
Yes, sir.
So both these blocks are going to move with a velocity v by 2. That's enough. From here you can find out everything. Yes or no? From here you can find out everything. How you can find out everything? Now, what will be the mean position of this SHM?
Same, sir.
Same, sir.
That
Na?
is of M1 means initial mass.
That means this is also the maximum velocity, no, sir? Yes, sir or no, sir?
Yes, sir.
Yes, sir, no, sir. And we know everything that, no, sir. So now we can do it in 10,000 different ways. So you know the maximum velocity of this block will be equal to v by 2, and that must be equal to what? What, my dear friends? Amitabh Bachchan or Shah Rukh Khan?
A omega, sir.
A omega. No Amitabh Bachchan, no Shah Rukh Khan. A into omega. And how much is omega? Huh? How much is omega?
K by 2m, sir.
Omega is k by 2m. K by 2m or root over k by 2m?
Root over K by 2m.
That's it. So v by 2 is equal to a times root over k by 2m. From there you get the value of a. M by 2k ka root multiplied by v. Do we understand this, or this has gone above our head saying bye bye sir, ho gaya आपको, enough we had.
Yes, sir.
This is one way of doing it. The other way of doing it, we can do it in a different way also.
Sir, we can do it by like work energy theorem also,
Yes,
no?
yes, you can. The total kinetic energy, this is the mean position. The total energy is in the form of kinetic energy, half 2m into v square by 4.
Yes, sir.
Total energy is in the form of kinetic energy. When it is going to the maximum state, amplitude, compressed, the total energy will be stored in the form of potential energy, half k square. From here also you will get the same thing. Trust me. From here also you will get the same thing. Because from here only this equation has been arrived. That is why I said that this question could be done in multiple ways. We understand it, or this has gone above and saying bye bye sir, ho gaya. Enough.
Understood, sir.
Now remember, law of conservation of energy is a very important aspect for this motion to remain simple harmonic, because if friction was there, this motion would definitely not have remained simple harmonic. Yes or no? No, yes.
Yes, sir.
Can there be a case where friction is present, but still the motion is simple harmonic? Huh?
Yes, sir.
Which case, sir? Yes, sir. Since I have said, then yes, sir. Yes, sir. Which case, sir? How can that case be possible?
Work done by friction will be equals to 0.
Good. There can be a case where friction is present, but work done by friction is zero. So you will see rolling of bodies attached to a spring. I will see if I can do those questions or not. If we get enough time, probably I will do it. If we not, I'll just skip it. There are questions where friction is present, but still the motion can be simple harmonic if the work done by the friction on the entire system is zero. And this is an example of that question. A simpler one though. I call it one. It's not actually question number one. The coefficient of friction between the two blocks is mu. See, friction from Newton's law of motion now coming in SHM. That is the problem with physics. And the horizontal plane is smooth, thank God. The system is slightly displaced and released. Find the time period. First question. Second question, find the magnitude of frictional force between the blocks when the displacement from the mean position is x. So this will remind us of everything that we have done from Newton laws till now. Revision. What can be the maximum amplitude if the upper block does not slip with respect to the lower block? Three questions. Reminder of everything that we have done till now. If you can do this, well done. If you can't, well, I won't complain much. 2 minutes you have to show me your talents. One or two parts are very easy. Everything is very easy if you understand it. 2 minutes you have. So how are you supposed to do this? The first question is very simple. If the system is slightly displaced and released, find the time period. What is the answer for that one?
Under root m plus m by k, sir. 2 pi under root m plus m by k.
That is simple. The second question is find the magnitude of frictional force between the blocks when the displacement from the main position is x. Now these two blocks are moving together. So when the displacement from the main position is x, my dear friend, then what would be the acceleration of both the blocks, because they are moving together, SHM? What will be the acceleration? Acceleration of the block will be equal to, I am not writing the negative sign. It will be omega square into x. Yes or no? No, yes.
Yes, sir.
And omega square is what? K upon capital M plus small m. Yes or no?
Yes, sir.
Multiplied by x. That is the acceleration. Yes or no? Yes or no?
Yes, sir.
Now remember, the lower block is experiencing the spring force as well as the frictional force, as well as gravity, as well as normal reaction from the upper block and normal reaction from ground. Now, Forget about that lower block. Concentrate on the upper block. Because of which force is this upper block executing SHM?
Friction.
This is the acceleration of the block. If I multiply it by the mass, so the force on the lower block, force on the upper block of mass m will be what? Will be equal to how much? This will be equal to how much? Small m into k into x upon capital M plus small m. And who is going to give this force? There's only one thing that can give it this force, and that is what? The static friction. Yes or no? That is the value of static friction. Do we understand this, or this has gone above and it's saying bye bye sir, bahut ho gaya. Enough for today. Leave it, leave us. We want to go back home. You understand this?
Yes, sir.
So the value of static friction is m by m, capital M plus small m into k multiplied by x. So far so good? So far so good? So far so good? Yes or no?
Yes, sir.
So far so good means that we have understood up till this point. Have we understood up till this point?
Yes, sir.
Now, you have to find out the maximum amplitude. Why you have to find out the maximum amplitude? Where is this frictional force has to be maximum? Because it is directly proportional to x. So the maximum value of this frictional force, where you will have to have the maximum frictional force, F max, that will be equal to m k upon m plus capital M multiplied by a when the block is in its maximum position amplitude. Yes or no?
Yes, sir.
And this maximum value of frictional force is always was less than or equal to.
Kinetic friction. Limiting friction, sir. Sorry.
Thank God. And what is the value of limiting friction?
Mu into n.
And what is the value of n for this block?
Mg.
See, so good, so good. So this m will get cancelled, and you will get a less than or equal to mu g into m plus capital M by k. So a has to be less than this. What is the maximum value of a? The equal value is the maximum value of a, and that is the maximum possible amplitude. Mu g upon mu g multiplied by capital M plus small m divided by k. That is the maximum possible value of acceleration of this system. Do we understand this? Or this has gone above and it's saying bye bye sir, bye bye sir, bye bye sir.
Understood, sir.
Understood, sir? Yes or no, sir?
Yes, sir.
Have you noted it down?
Yes, sir.
Okay, then we move on to the next heading, and we can write the next heading: combination of springs. Combination of springs. And what are the combination of springs? Have you seen this combination of springs? The first combination is known as the series combination. Have you heard or seen this combination?
Yes, sir.
Series combination. So what happens in series combination? I will just show you the. Everyone knows this, na? Yes or no? So what happens in this series combination? If you have two springs placed like this, they are said to be in series combination. Yes or no?
Yes, sir.
In this case, uh, both of these will have different displacements, x1 and x2. Their displacements are different. Do we know this?
Yes, sir.
So their displacements are different. X1 and x2, they have different displacement. They get both the extensions in the springs are different. Do we understand this? So what is the first thing that you have to remember? X is different. All the both of the springs get extended or compressed by different, but the force acting on the spring is same. Do we remember this? Do we know this? Do we understand this?
Yes, sir.
So now I can write the force acting on both the springs will be K1 X1 will be equal to K2 X2. Yes or no? And this also
Yes.
can be written as let me. So do we understand this? Yes or no?
Yes, sir.
Okay. Now if I say that this x1 plus x2 is the total displacement x, now I can write this. These are the three equations that you have to remember. This can be written as k effective multiplied by x. Do we understand this?
Yes, sir.
Anyone knows this? Yes or no?
Yes, sir.
Using equation number 1 and 2, I can understand that 1 by k effective will be equal to 1 by k1 plus 1 by k2. Yes or no? So basically what I can do is I can replace these two spring by a single spring. Yes or no?
Yes, sir.
And the spring constant of that effective spring becomes k effective. So I can write in series combination 1 by k effective is summation of 1 by ki. Yes or no? No, yes. Then the
Yes, sir.
time period or omega in this case will be under root of k effective by m. Everyone knows this?
Yes, sir.
Okay, this is known as the series combination of springs. We will go ahead with the series combination. There is one more combination which is known as the parallel combination of springs. Time was not sufficient enough to cover both of these. So we will cover the series and parallel combination again in the next class, and this will finish this part of this, and then we'll move on to other types of SHM, and probably by next class we should be able to complete all of this. Everyone understands what we have done in today's class?
Yes, sir.
Okay, then we'll meet in tomorrow's class, and in tomorrow's class, it's a long class. I will see if we can finish this SHM by tomorrow. Take care. God bless you all.